Okay, so these are going to be a series of like one problem at a time videos, but if you follow them in order, it's going to take us through the whole sheet. So I'm just going to go through the ones that we did in class and a couple that we didn't, just so we've got some reference ones. So talking about free body diagram examples that we did in class. We'll start with number one. So we're going to draw a free body diagram for a 30 kilogram box sitting on a flat surface. So let's draw our flat surface. And then I'm going to adjust the camera here just a little bit. And then we'll put our box, put our dot to indicate the center. And if that's a 30 kilogram box, remember that force is equal to mass times acceleration, or in this case, mass times gravity, and we could refer to that as weight as well. So I'm going to let you get away with using 10 meters per second squared for gravity for your examples. So if this is a 30 kilogram box, gravity is 10 meters per second squared, that's going to be 300 kilogram meters per second squared, or 300 newtons. Okay, so we'll draw our force of gravity. It's 300 newtons. And if there were no other forces, that thing would be accelerating downwards. And we can see that we've got a support force from our surface, which is equal to that. So our normal force is also 300 newtons. And so the forces on our box are in balance, and its net force is 0. And so there is no acceleration. And that's how we start with a real simple free body diagram. All right, so let's do number 2 quick, and then we'll break and switch to the other ones. So if you have a baseball thrown through the air, that ball is probably going to be doing some path like this. Now, once it leaves your hand, we represent the baseball with a box. It's not supported by anything. We don't know what the force is, so we're just going to call it the force of gravity. Now, there is no support force here. There's no more force accelerating that object, so it should just be moving with a constant speed because we can explain that with Newton's first law. If you wanted to, you might choose to put a small amount of air resistance on this thing, but I'm not going to do it for this one. So those are 2 simple free body diagrams to get us started.